All right, ladies and gentlemen, we are starting up our final new little area here of our year together. We are doing a little statistical work here these last couple of sections. Some of them you may be very familiar with, others maybe not so much, but we're also going to show you some calculator ways to help shorten things up a little bit. So, measures of central tendency, okay? Mean, another word you may have heard of here somewhat often, is an average. You're going to add up all your data points and divide by the numbers in the data. It's like how you find an average in anything. The biggest thing here is going to be best used when the data set has no outliers. Now, what's an outlier? A number that's kind of very outside the range that you are in. So like if you were doing like a teacher and you're looking at test scores, and the test scores are like 95, 83, 96, 82, 2, like that 2 is going to make the average look awful when it's really not. So that would not be a good time to use an average or a mean. However, then there's the median, the middle number, or the mean of the two middle numbers of ordered data. You take all your numbers, you put them in order from least to greatest, and you can find the median. You can have outliers here, so like the situation I was just talking about with the grades, but there'd be big gaps in the middle. Okay, you can't have a big gap in the middle, but if they're kind of close, you get the one or two numbers that are way out, the median will help you get a more accurate depiction of that. Mode, the number of numbers that occur most often. Well, that's real simple. If you have a bunch of repeated numbers, the mode is probably going to be your best option. And we'll save the margin of sampling error for a little bit later, because that's more when we're looking at surveys and things like that to see just how accurate they would be. Okay, first example. Which measure of central tendency best represents the data and why? Well, here you have, like these numbers are all real close to each other. This one's kind of out of range. That one's way out of range. So, but the numbers in the middle are all pretty close together. So the median would represent this data best. And I'd find that by working my way into the middle. So in this case, I would add those two up and divide by 2. So in this case, my median would be 22.55. And that would be a more accurate depiction than a mean would. Margin of sampling error. Okay, we'll discuss this real quick. We'll see it more a little later in the lesson. Of 400 people surveyed in a national poll, 51% say they will vote for candidate Gonzalez. Since 400 people are surveyed, the margin of sampling error is 1 over n, the number of people that I surveyed. So if I bust that out on my calculator, if I do 1 divided by the square root of 400, okay, there's where the 5% is coming from. So what you would do is you would add and subtract that 5%. 51 minus 5 is 46. 51 plus 5 is 56. That would be the likely interval that would be accurate for that case. Okay, so for all of these, which measure of central tendency best represents the data and why? We're not calculating it yet. We will. But here I'm looking around. I'm like, all right, what do I notice? Hey, wait a minute. Half the numbers here are 45. Mode would be best. It's the number that's occurring most often. Or I look at the next one, and I'm like, those are kind of close. That's like way out there. So that would be a good example of an outlier. And so that means we wouldn't use mean. None of them repeat. We can't use mode. So median would be my best option there. Look at this next one. We got an outlier again. So median would be my best option. And then this last one, I'm not seeing a bunch of repeats. And those numbers are all fairly close to each other. So this is one we're using the mean or the average. Would be okay to do. So, we are going to get to some math here, I promise. Okay. A survey of 28 random people found that 40% read at least 3 books a month. What's the margin of sampling error? Okay. first thing, plus or minus 1 divided by the square root of what's our n value. So 1 divided by the square root of 28. Again, you're looking at this as a percentage. So about 18.9%. So what I'm going to do is I'm going to take the 40 and I'm going to subtract 18.9%. And I'm going to take the 40 and I'm going to add 18.9%. That isn't a real accurate, I mean 20 to 60 almost. It's probably need to survey a few more people. Okay, so then the other part of this that we can deal with math is figuring out the measure of variation. It lets you see how closely a set of data clusters about the mean. You know, how far off are we going to be if we're hitting either any of the extremes that we have from our data. Now again, luckily for us, here's these formulas. We're not going to need them. Not going to need them. I'll repeat that. Your main thing you have to keep track of here is it a sample, a small piece of the population, or is it a population, which is all samples or some? Okay. The symbols we'll talk about in a bit because we're going to be doing some of this stuff on the calculator. But speaking of the calculator, there is a chart after this that does a very nice breakdown of all this stuff. But for right now, I'm just going to kind of write it here so we start to think about it a little bit. So when you're looking for these, you're going to go to the Stat button right there. Okay. And when you're putting in data, to do your data, you're going to want number 1, edit. Because this is where you're going to put in all your values. Now, if there's a bunch of values there already that you don't need and you want to get rid of them, yes, you could delete them one by one. Or you can just go to the top of the list and hit clear. And when you come back down, they're all gone. Otherwise, I mean, could I just go by and hit clear? Or delete, 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 delete. Yeah, that works too. Okay, so I'm going to enter my information in there. So normally we're going to put our info in list 1. So it just makes sense. It's the first one there. That's the one we do. Then, to get the actual standard deviation, we are going to go back to the stat menu. We're going to arrow over to calc, and we are going to be doing number 1, which stands for variance statistics. So you would take that, you would hit calculate, and I'll show you where we're going to be looking for stuff in a moment with that. But that's the general idea of where you're going to be punching your information in and finding your answers as you go. And again, if you flip forward a couple of pages in your notes, real nice layout of everything there. But let's actually do one of these. So for the following data, figure out if it's a sample or population, then find the standard deviation. The test scores of 12 students in a mathematics course are displayed below. Because the scores of all 12 are enrolled, this is a population. Okay, you're being given that this time. Normally it'll say some, part, things like that if it's not going to be a population, if it's going to be a sample. So here, my first job is to grab my calculator, and I'm going to start this. So I'm going to go to Stat, I'm going to edit. Again, if you had a bunch of stuff in here before you start, just scroll up to the top of your list and hit clear one time, and when you come back down, it'll all be gone. So for the moment here, I'm going to come down so we can see all of our numbers. And just hit enter as you do each one. That'll keep moving them down the list for you. Now, one thing I have run into in the past is, well, how do I make sure I don't skip a number or miss a number or something like that? Here's my way of doing it. In the parentheses, there's this little number, 12. That should go with the number of data points you were putting in. So if you know you're putting in 12 numbers and the last number is 12, you probably did it right. So once we get those all in, move this back down so we can see this, we're going to go back to the stat menu. We're going to arrow over to calc, and we want number 1. Okay, we want the variance stats. So we want to, once we get here, we want to calculate. We want them to actually do some stuff. So what's all this stuff, and what's useful to me and what's not? Okay, the x with the line over it is the mean. So there's the average. So 81.4. Okay, so we get that in there. Then, just changing up one thing as I go here, the standard deviation. Now, if I look back up here, you notice for samples, it looks like there's an S in front of the X. That, if you're a sample, that would be your standard deviation. But if you have the whole population, okay, again, notice the symbol, that's the one that you want. So 12.65 or 12.7 if we were going to the nearest value. And that's what we're looking for. You're like, that's all I'm looking for out of here? That's all. I mean, I can find other stuff, but I don't really need it right now. And so again, there's how to clear things off. There's what your values are going to look like again. Just kind of a reminder. There's the mean. There is your sample standard deviation. There is your population standard deviation. Those are the main 3 things that we are going to be on the lookout for when we are doing these. Okay, so one last time, just to be sure, and then we'll wrap this one up. Not a long one today. So determine whether this is a sample or population. The test scores of sum. This is going to be a sample. So just like what we were doing a moment ago, we're going to go to stat. We're going to do edit in the list here. We don't want all those. So up to L1 and clear right below here. We'll wipe those out and arrow down. Miraculously, they're gone. And now we're ready to start typing these in. Okay, once again, I noticed 2, 4, 6, 8, 10. There's 12 data items. That's what I've got here. I'm feeling good. So we go to stat, go over to calc. We want number 1, and we want to calculate. So again, I know they're not asking me for the mean and all this other stuff, but again, doesn't hurt to get one more example of that. But this time, since it's a sample, I want that one. And again, looks like we're going to the nearest 10th right now. That would be, oops, sorry about that. That would be 6.6. So as we normally do here, I gave you a freebie. Over here on 7.5 in your new practice packet, we're looking at pages 1 or 2, odd or even. You know how this works. They're either on the sheet or posted on Classroom. Give them a shot. We got one section to go. We'll see you then for that.